Good evening, everyone. I am Joey Scherenbach, and here we go again with the 2024 to 2025 winter weather forecast. Believe it or not, it's that time of year where winter is approaching very quickly, and let's see what's heading in our direction this year. So, as always, when looking at winter, the first thing we look at is the Pacific Ocean. So, all credit to Tropical Tidbits for this photo, by the way. Thank you very much. But regardless, with the Pacific Ocean, you're going to have two different phases for each season, and these can last for a season, they can last for half a year, they can even last for an entire year. But regardless, for this winter, you, again, either two phases. You have an El Nino phase, which is the warming of the waters off the Pacific Ocean. This is the equatorial view here. Or you can have La Nina, which is the cooling of the waters off the Pacific Ocean. You can also have an Enso neutral, which means it's not a La Nina or an El Nino, it's just that sea surface temperatures are very much neutral, and both phases can be either weak, they can be neutral, they can be strong. This year what we have is a weak La Nina. So you notice these anomalies here of cooler waters than average, of course, off the Pacific Ocean. So this is the anomaly guide over here. But again, the blue is indicating cooler than average, the red is indicating warmer than average. So this is a La Nina winter, and what also plays a pivotal role in our patterns here in New England, which is up in the northeast there, is the positioning of it. Is it westerly based, is it centrally based, or is it easterly based? This year we have a central to easterly based La Nina, and that cool water from La Nina is going to help generate an upper air pattern for the whole lower 48, and really everywhere for that matter, but focusing on the United States, it's going to create a certain pattern. And depending on where it sets up, depending on how strong it is, will dictate what pattern it sets up. But often with a weak La Nina, especially in the central to easterly positioning, it's going to habitually create more of a ridge up in Alaska and down in the western Canada towards Siberia, and as well as the west coast, and then create more of a trough down in the eastern United States. Now, a ridge is an area of high atmospheric pressure. So when an area is under a ridge, generally it favors warmer than average conditions. And again, it's all relative to normal. So in winter, a ridge could be 40 to 50 degrees in New England. Meanwhile, in the summer, it can be 100 degrees. Meanwhile, a trough is the opposite. That is an area of low atmospheric pressure, and generally when you are under a trough, you have colder than average conditions, and sometimes a little bit of a stormier pattern as well. Not always, but sometimes. So a central to easterly based La Nina does have the habit of creating more, again, of a ridge up in Alaska, which is what is called a negative East Pacific oscillation. And a lot of times, when you have a negative East Pacific oscillation and or a ridge up in Alaska and on the west coast, generally favors a trough in the east, which would favor colder than average conditions. And for the next couple weeks, and more on this pattern in just a little bit, we are seeing that happen. We have a ridge developing in Alaska and the west coast, and then which therefore favors colder than average conditions for the east coast. But at the same time, there's questions to how much it lasts and where this moves. Does the La Nina trend stronger? Does it trend weaker? Obviously plays a pivotal role. And although the background state of La Nina may favor a pattern like this, it doesn't necessarily mean that it's going to hold its course. And what La Nina patterns do like to do is have some cold earlier in the season for the eastern United States, more of a ridge in Alaska and on the west coast. But then later on in the season, it likes to flex what's called the southeast ridge. So that is the opposite. That would be a trough in Alaska and or the west coast, and more of a ridge on the east coast. So the month-by-month breakdown I'll get into in just a little bit, but that's kind of a background of what La Nina patterns generally tend to favor weather-wise. So, just talked about the Pacific and what the oceans are looking like. Now, another big factor is the polar vortex. So, we talked about the Pacific first, now we're moving on to the Arctic. So what's the polar vortex? Well, the polar vortex is a strong current of really cold air way up in the atmosphere, in the stratosphere actually, up in the Arctic. And also credit to NOAA for this picture, by the way, thank you. And these are two polar opposites. So a stable and or strong polar vortex, as you see here on the left, favors a generally milder pattern for the lower 48. Not always, and its positioning matters heavily as well, which again, more on that in just a little bit. But generally speaking, when the polar vortex is strong, it keeps all of the really cold Arctic air up in Canada and in the Arctic and prevents it from coming down into the lower 48. So historically, when we have had these record cold outbreaks in Boston, where you have sub-zero temperatures, freezing cold for somewhat extended periods of time, that is almost always due to a weaker polar vortex, or at least a temporary phase where the polar vortex stretches, or at least a part of it heads down. When the polar vortex is strong, it's much more unlikely for that to happen. Meanwhile, on the flip side, when the polar vortex is weak, as this model shows, warmer air gets into the Arctic to dislodge that cold from the north. Therefore, that cold air from the north gets sent down into the lower 48. Not necessarily just to the northeast, it can be sent down to the Midwest, which happened in 2020-2021, where there was a significant polar vortex disruption, but the cold air did not really head southeast towards the northeast, rather it headed down south, directly south, and areas like Wisconsin and even Texas got really big cold out of that. So when it gets disrupted and it's weak, as this model shows, where it does get disrupted or where it heads is not the same every single time. But this is still a general model of what's going on. Now, the polar vortex generally is looking to be on the stronger side for right now, but more on that in just a little bit. So this is a model of the polar vortex and what it might do in the next, over the next couple weeks. Now again, keyword model. Models generally are not the most accurate with the polar vortex. That's not to say that this model is wrong, but it is really hard to predict what the polar vortex does in the future. All that can really be considered is what's going on with it now, and then just to see what happens in the future. Again, it's really a day-by-day process. But regardless, as of right now, there are no signs of a big polar vortex disruption. So this is at the end of this run here. This is in mid-December, and again, it may pan out like this, it might not, but assuming that this model at least has a somewhat decent representation of what may happen, this is indicating a strong polar vortex. Not crazy strong, not record strong, but generally pretty compacted. You notice these pretty circular isobars here, and where it's located up north. That is indicating that a lot of this cold air that the polar vortex is keeping is going to be concentrated up in the Arctic, around Siberia, perhaps in Greenland, but again, this map is a little bit modified as well. So, will that happen? Again, it remains to be seen, but a look like this would indicate that a deep cold outbreak is a little bit hard to come by because if all this cold air is locked up in the Arctic, it's really hard to get it dislodged. However, the polar vortex is by no means the #1 dictator of the pattern. Some years it has more influence than others, and again, going back historically, La Nina winters do tend to favor more polar vortex disruptions. The exact reason for it is not exactly clear, but in La Nina winters, polar vortex disruptions are more prone to happen. However, they are more prone to happen in later on in the season, not so much in December and January. And that is what's being referenced here. So, logistically speaking, a look like this does make sense for it to be rather strong in mid-December and then perhaps weaken as the winter goes on, which does remain to be seen. But if the cold that is going to show up for the Northeast over the next couple of weeks is not due to the polar vortex, it's due to the Pacific and blocking, which will be described in just a minute. So again, this is another model, and it may not be 100% accurate, but given the date today and what is always forecasted to head on in the future, there is pretty solid model consensus of what happens over these next couple weeks. So, what's going on here, and I know it is moving pretty quickly, is, and as I mentioned earlier, whether a ridge or a trough develops in Alaska and on the West Coast is pivotal to what happens on the East Coast. Not always, but a lot of times, what is happening on the West Coast and in Alaska, the opposite is happening on the East Coast. So if a ridge is developing in Alaska and or the West Coast, so you have a negative East Pacific Oscillation, as previously mentioned, and the PNA, which is the Pacific North American Oscillation, that corresponds to what is happening on the West Coast. So when the PNA is positive, that's indicating a western ridge. When the PNA is negative, it's indicating a western trough. And what's happening here, and the colors can be a little bit misleading, but following these isobars is a ridge is developing in Alaska and on the West Coast. Therefore, it's sending colder air eastward with what we like to call a cross-polar flow, which means cold air is moving northwest to southeast, and in this case, it's hitting the northeast and the eastern part of the lower 48 for these next couple weeks. So, again, that means colder than average temperatures generally for the Northeast over the next couple of weeks. But does it last super long after that? Remains to be seen, and more on that in a second. But it also means that relative to the averages. So these colors can be a little bit misleading. You know, when you see these deep blues, it doesn't automatically mean it's going to be freezing cold. But given the average temperatures in December are in, at least in the earlier part, they're in about the low to mid 40s. So these averages balancing out would probably be in like the 20s and 30s for high temperatures with this current pattern. Now, this is at the end of the run, however, and I've paused this so it's a little bit easier to explain. Now, it's also worth noting that this is in mid-December, so this is about 2 weeks from now. And this is where the colors can be pretty misleading because of these ensemble members that we look at to try to make these longer range forecasts. There are many members of each ensemble, and this is the mean of everything, so the average of all the members. So therefore, they have to kind of balance out and level off the further out you get in range because there is so much spread among the individual members. So this is just an average. However, looking at the isobars here, you can see that in mid-December, what was forecasted to be, an eastern trough and a western ridge for the first half of December still has happened. This is mid-December. But it is showing signs of kind of lessening and backing off a little bit in mid-December. Now again, this is just one model, but there is pretty solid model consensus on this as well, that after a couple weeks of a colder pattern for the Northeast, it will tend to kind of level off. But then the question is, does the pattern totally flip, and do we go from a western ridge and an eastern trough to a western trough and an eastern ridge? That remains to be seen. It's a little bit hard to say. But for right now, what's looking more likely is the pattern just kind of levels off. So the Northeast goes from a colder than average pattern for 2 weeks to more of a seasonal to slightly above average pattern perhaps. But notice there is still a ridge here in Alaska. Again, weaker than it would have been 2 weeks ago, but still present. And a little bit of a western ridge here. Again, not as pronounced, but still there. But it is also showing signs, and again, it's a little bit hard to see, but looking on the isobars here, when they raise, it indicates a ridge. When they dip, it indicates a trough. And you notice that it's starting to indicate a little bit of an eastern ridge developing here and more of a trough down in the Midwest, kind of like a ridge on both coasts pattern. This is rather interesting. It doesn't really appear that often. A ridge on both coasts or a trough on both coasts is a lot more common in the summer months. So this is a little bit of an interesting outlook, but it can't be ruled out. So for some more analytical tools here, judging by all of what the guidance has been saying and what long range and historical data does present, for December, as I mentioned earlier, I definitely would favor a rather tale of two halves, so to speak, or an uneven month. So the confidence continues to increase that December to start will be on the colder side. Again, all relative to average. So what does cold mean in December in the Northeast? Well, it probably means a lot of days in the 30s, nights in the teens and 20s, so cold enough to support snow. However, the pattern looks relatively dry during this cold stretch as well. There are some hints of some smaller storms, perhaps some light to maybe moderate snow events, but no big storms are in sight right now for the first half of the month. The second half, though, there are signs of it changing a little bit. So as I mentioned earlier, the cold looks to kind of level off after the first half of the month, but then I do think the pattern is going to get a little more active as well. But the question is, will the temperature still be cold enough to support snow? Again, remains to be seen. That goes into a specific storm track. So where do the storms track? Do they track west of the coast? Do they track right through? Or do they track further offshore? So with temperatures being closer to average, that would lead to kind of a battleground. But regardless, I do think that December will start off cold, finish a little bit milder temperature-wise, but the opposite will happen storm-wise. And then regarding January, so again, historically in La Nina winters, they tend to be rather front-loaded. And then that means that the most active periods of winter weather, for the Northeast anyway, come in the first half of winter, in December and the first half of January. Expecting that to happen again this year, given the cold that's already setting up for December in the first half. And also, while we're on this topic, it's worth mentioning that Boston has not recorded a cooler than average winter month, in quite a long time. Not totally sure the last time it happened, but it has been quite a long time. December is going to be close. Definitely it will be colder than average through the first half. Will it hold on, though, for the average in the second half? Not so sure. But that just goes to show the front-loaded mechanism to winter in a weak La Nina winter. Again, more so in the first half of the season. So I think that active pattern that kicks off in mid-December will continue through the first half of January with, again, some chances for cold. I definitely don't think it's going to be super mild. I do not expect a January thaw in the first half, but I could see a January thaw in the second half because, again, historically, the La Nina winters, the southeast ridge likes to flex later on in the season. And for that reason, by the time we get to February, a lot of times February is really mild in La Nina winters for the East Coast because the southeast ridge has flexed and there's not a lot of cold air left from the Pacific. A lot of times that Pacific cold comes early in the season, which is happening this year, but then it kind of backs off, and so therefore warmth from the south is able to flood in a little bit more. However, that is where the polar vortex comes into play, because what the polar vortex also corresponds to directly is high latitude blocking. So high latitude blocking is basically any ridging and heat that gets into the Arctic. So what heat and ridging get into the Arctic is, again, sends cold down into the lower 48, and it also kind of squashes and prevents the southeast ridge, or any ridge for that matter, from flexing northward. So if there is a lot of high latitude blocking, a southeast ridge struggles really very much to creep northward, because the blocking is, again, as blocking as it's described, blocks it from flexing northward. But in order to generate high latitude blocking, the polar vortex often needs to be weak, because, as mentioned earlier, when the polar vortex is strong, it sucks up a lot of that cold air and keeps it up north. And high latitude blocking is ridging and warmth that gets into the Arctic. So what a strong polar vortex does is keep a lot of the cold in the Arctic and prevent heat from getting in. Therefore, with a strong polar vortex, high latitude blocking is very hard to come by. It's not impossible, but it's very hard to come by. Now, I mentioned stratospheric influence here because, again, as mentioned earlier, La Nina winters do tend to favor more polar vortex disruptions. So if the polar vortex does get disrupted and high latitude blocking does develop in January and February, which, again, is not forecasted to happen, but it can, because the stratosphere and the polar vortex are so difficult to predict in the future, that could perhaps get in the way of the traditional February pattern for La Nina. So while for right now, I do expect a warmer February and perhaps active, but favoring more rain due to the lack of cold air, the stratosphere could get in the way here and totally throw this forecast off. So that's why I put this as a question mark, but it is something to keep in mind as we head into the latter part of winter. And now we get to March, which is always a very, very fun month in New England. You know, historically, over the past few years, actually, March has been quieter than usual. But back from like 2010 through 2018, give or take, March, that doesn't mean every March was a super snowy month, but we had a lot of crazy Marches, and some winters within that 8-year span, March was actually the snowiest month of the season. Go figure. Through December, January, and February, more snow actually fell in March than all of those months combined, in some of those winters, which is really crazy thinking about it. Regardless, for this year, I do not expect that. I think the most snow that will fall in New England this winter is from mid-December to mid-January. I don't expect March to provide more snow than that. However, I do see a little bit of a surge of winter early on in March, especially if we do get a polar vortex disruption in January and or February. If the polar vortex does get disrupted, and depending on where it gets disrupted and or split, it takes at least a few weeks, sometimes even a month, for those effects to start kicking in. So therefore, if a disruption happened on the northern side of the hemisphere in mid-January, effects would not be felt here locally until mid-February, most likely. Also worth noting that the polar vortex is in the stratosphere. So that is the second layer of the atmosphere, but we here live in the troposphere. So after warming gets into the stratosphere to promote a polar vortex disruption, if it does, that is only one piece of the puzzle, because after that, the warmth that got into the Arctic needs to dislodge the cold that then couples with the troposphere, which is where we live. So in order to feel effects here in the troposphere, the stratosphere and troposphere need to couple, which again is a big if, and it is really difficult to predict out in advance. But regardless, for March, do you think a surge of winter early on is very possible? I think that first week of March will definitely have a couple storm chances, perhaps enough cold to support some snow. But I do not expect it to linger. I think once we get to the second half of March, it's going to be generally milder. Again, barring any significant late polar vortex disruption, I think March will generally be on the mild side, especially as the month wears on and we head towards spring. The final call for winter this season for Boston, going with 35 to 45 inches. This is actually a little bit aggressive here, and many forecasts would likely be a little bit lower. And kind of summary of this entire forecast, I know I've kind of laid on a lot for you, and I really appreciate everyone listening. There are a lot of conflicting factors. Last winter, the signs were pretty clear for a warmer and drier winter, so the forecast was not quite as difficult, and that's exactly what happened. It was a little bit milder than everyone thought, despite everyone thinking it was going to be a mild winter. It was, like, exceptionally mild. Boston did not even get 10 inches of snow. It was ridiculously below average. Meanwhile, the winter before, Boston only got, I believe, like 12 or 13 inches, yet last year managed to be worse. So it's easy to say, oh, well, there's no possible way Boston could get less snow this year than it did last year, right? Well, there is a possible way, because Boston did not get 0 inches last year, but I think it's pretty unlikely. The oceans this year are drastically different than last year. There are a lot of different signs as well. There are some similarities, but the Pacific, as mentioned earlier, is drastically different. The pattern setting up in December is a lot different. So I do not expect a repeat of last year. I think this winter will overall be warmer than average, and the average snowfall in Boston is, I think, right around 45 inches. So therefore, this forecast is for a near to around average snowfall in Boston, but still warmer than average. Again, a little bit aggressive here. There are a lot of conflicting signs, so it's a really, really complicated forecast. And weak La Nina winters, some of them have been really quiet, but some of them have really boomed, and Boston has gotten a big winter. So again, really, really hard to say. So I'm going to take a middle ground here and go with 35 to 45 inches. Again, this is for Boston and along the coastline. Inland, I definitely think we'll get more, and especially later on in the season where that southeast ridge tries to flex, it will generally favor storms to track further west, not so much coastal, but more right through New England or west. And if that happens, that would definitely favor inland to get more snow than Boston. So for that reason, I think inland will get more, like 50 to 60 perhaps. Boston, a little bit less, but still close to its average for the season. So that is my best guess. I would love to hear everyone else's, though. So please, if you want to talk to me in the comments of this video or reach out to me on Twitter, I would love to chat with you there. Thank you all so much for watching this. I really do appreciate it. Here's to a snowy winter, and we will see what happens.